Let's discuss Unit 1 Discrete Structures and Optimization questions. In a group of 120 people, 65 eat rice, 45 eat bread, 42 eat curd, 20 eat both rice and bread, 25 eat both rice and curd, 15 eat both bread and curd, and 8 eat all the three items. Which of the following is the number of people who eat at least one of the three items? Let's take capital R as the group of people who eat rice. So R is equal to 65 from the given data. B denotes bread eating people, so it is 45. C denotes curd eating people, it is a count of 42. We have the data for both rice and bread. So we denote it using intersection operation here. R intersection B for rice and bread will be 20. R intersection C for rice and curd will be 25. B intersection C for bread and curd will be equal to 15. And we have 8 eat all three items, which is denoted by R intersection B intersection C. We have the total count of people to be 120 here. So out of these 120 people, we have to find how many people eat at least one item. We are going to apply the concept of principle of inclusion exclusion. R union B union C means it's the number of people who eat at least one of the three items. So why have we used this notation is to take only the count. This is given by the count of R, the count of B, the count of C minus the count of R intersection B minus the count of R intersection C minus the count of B intersection C plus the count of R intersection B intersection C. We are going to directly apply the value. R is 65, B is 45, C is 42. We are just taking this minus outside and then adding all these three together. So what is R intersection B? It is 20. What is R intersection C? It is 25. What is B intersection C? It is 15. Then we are adding the intersection of all these three items, which is 8. 65 plus 45 plus 42 will give you 152 minus 20 plus 25 plus 15 will give a count of 60, then this plus 8. 152 plus 8 will give you 160. 160 minus 60 will give you 100. So altogether 100 people eat at least one of the three items. So they have given a count of 120 people. If 100 people are going to eat one of the three items, from this you can also take another count. 20 people will eat none of the three items. So out of these 120, if 100 are going to take at least one item, then definitely 20 people are going to eat none of them. In case if the question is going to be about the number of people who eat none of the three items, then using the same formula you have to find it as 100 and then subtract it from the total group of people. Let's see this particular food preference in the form of Venn diagram. They have given the value for rice, bread and curd separately. It means this rice value 65 includes this 20 and this 25 also. Say for example, if you take 28 plus 12, it will give a count of 40. 40 plus 17 will give 57. 57 plus 8 will give 65. So totally there are 65 people who eat rice. 65 includes people who eat only rice, people who eat rice and bread, people who eat rice and curd, people who eat rice, bread and curd. 65 is the total count of people who eat rice here. So in order to find only rice, you have to exclude bread, curd and bread and curd combination totally. That's how we have brought it to 28 here. Now, how do we get 100 from this particular diagram? 28 plus 12 will give you 40. 40 plus 25 will give you 65. 65 plus 10 will give you 75. 75 plus another 25 will give you 100. Overall, when you add all the numbers in the Venn diagram, you will get 100, which will tell that 100 number of people eat at least one of the three items. So from this we can mark option number 2, 100 as the right answer. Next question. In a pack of 42 cards, 3 cards are chosen one after the other. Find the number of ways this can be done without replacement. It means when you pick the first card out of the 42, you cannot replace it. So for the second picking, you will have only 41 cards. For the third card picking, you will have only 40 cards. This is the idea behind saying without replacement. Now let's see how to solve them. To find the number of ways to choose 3 cards, one after the other, without replacement from a pack of 42 cards, we have to use the concept of permutation since the order of selection matters here. So for without replacement, for the first card we will have 42 cards totally. So it is 42 choices. For the second card, one card is already selected. We have only 41 totally and we are not going to replace it. So out of 41 cards, you are going to choose the second card. For the third card, 2 cards are already taken. So you will have only 40 cards remaining. Out of that, we have to pick the third card. How will we find the total number of ways? You have to just multiply the choices of first card, second card and third card. For first card I have 42 choices. For the second card I have 41 choices. And for the third card I have 40 choices. 42 into 41 into 40 will give a count of 68,880. Option number 3 will be the right answer. This is the case for without replacement. What if the question is being asked as with replacement? We will see that also for learning purpose. If it is with replacement, when you are picking the first card, you will have 42 cards in total. So there are 42 choices. Here choices means it is the number of cards only. You need not confuse them. For the second card, since you are allowed to replace, you still have all the cards in the choice list. So again 42 choices are available. They say the first card is getting replaced. So you have 42 choices again. What about the third card? You are allowed to replace. So still you have 42 cards from which you can choose the third card. So the total number of ways here it will be 42 into 42 into 42, which will give a count of 74,088 ways totally. So if it is with replacement, you have to go in this way. When it is without replacement, you have to stick to this way. So the answer for this question is option 3. But I am just giving you, if the question is going to be with replacement, this will be the answer. Next question. A positive integer selected at random from the set of positive integers not exceeding 200. So you have to consider positive integers. This means you have to start from 1. And they say it is not exceeding 200, so the limit is going to be 200. Which of the following is the probability that the selected number is divisible by either 2 or 5? Already this question has been asked in one of the previous year question paper, but it was not exceeding 100 limit. Let's take A to be the numbers that are divisible by 2. How will we find numbers that are divisible by 2 mathematically? You have to take the floor value of the total positive integers. 200 numbers are there. Divide by the divisibility of the integer that is being asked. So the total value is given and the divisible number has to be given in the denominator and the floor value has to be taken for this numbers divisible by a particular integer. So there are totally 200 integers 1 to 200 and they are asking divisible by 2, so we are giving divided by 2. What is the floor value of 100? It is 100. There is no decimal point, so we are sticking to 100. What about numbers divisible by 5? Floor value of 200 divided by this particular number 5. 5 fours are 20, so it is floor of 40, which is equal to 40. So there are 100 numbers that are divisible by 2. Actually, in a count of 200, 100 will be odd and 100 will be even. All the even number will be divisible by 2. So this 100 count is right. Regarding the numbers divisible by 5, you have 40 count of numbers. If you don't go by this method, write in a piece of paper from 1 to 200 and start counting how many are divisible by 2 and how many are divisible by 5. and how many are going to be divisible by both 2 and 5, you will exactly get this count. A intersection B is given by the numbers divisible by both 2 and 5. So this is floor of, you have to take 200 and you have to multiply 2 into 5 here. It means it is divisible by both 2 and 5. So this will be 200 divided by 10 and this will give a value of 20. So 20 numbers are divisible by both 2 and 5 here. We are applying inclusion exclusion principle here again. A union B will give either 2 or 5 divisibility. So you are going to find A union B, which will say either or. This is count of A, this is count of B, and this is count of A intersection B. It means this is numbers divisible by 2, numbers divisible by 5, and numbers divisible by both 2 and 5. So A count will be 100, B count will be 40, and intersection will be 20. 100 plus 40 is 140. 140 minus 20 will give you 120. You have to take this probability of 2 or 5 is given by what is the total number here? 120 divided by what is the total count of integers? It is 200. Whenever you want to take probability of a particular event, it is the number of occurrences of that particular event divided by the sample space count. So here we consider the sample space to be 200 and the event occurrence will be 120. 4 3s are 12 and 4 5s are 20. So 3 divided by 5. Option number 2, 3 divided by 5 will be the right answer. If you are not fine with this particular way, if you think that a probability question has to be addressed with probability alone, we will go with this way. What is probability of A? We know there are 100 numbers that are divisible by 2. So 100 divided by 200, this will give a probability of 1 by 2. What about probability of B? 40 divided by 200. That is, for every value you are going to find probability and then apply it in the formula. This will give a value of 1 divided by 5. What about probability of A intersection B? This will be 20 divided by 200 and you will have 1 by 10 altogether. Now you have to apply this in probability of A union B, which is 2 or 5. So this is for 2, this is for 5 and this is for 2 and 5. 1 by 2 plus 1 by 5 minus 1 by 10. When you take LCM, it is 5 plus 2 minus 1 divided by 10. 5 plus 2 is 7, 7 minus 1 is 6. This will give a value of 6 divided by 10. 2 3s are 6 and 2 5s are 10. You are getting 3 by 5 in this way also. When I discuss one way in the video, some of the aspirants, they are giving the other way to solve in the comments. If you still have some other ways for any other questions, you are always free to mention them in the comments so that every one of us can learn an alternate way of solving the same question. Next question. Consider the Boolean expression A of x comma y comma z is equal to x into y dash z, and only this particular y dash and z are put under dash once again. Which of the following is complete sum of products form of the given Boolean expression? What is complete sum of products? The complete sum of products form means expressing the function as a sum of min terms. What are min terms? The terms where each variable appear in either complemented or in uncomplemented form. So basically this is given in an expression of A of x comma y comma z is equal to x into y dash z and then the whole dash. We have to bring it to a normal form so that we can express it in the form of min terms. So how are we going to solve this? First, let's take only this particular part, y dash z, the whole complement. When you apply De Morgan's law, you have to apply the complement inside and this product will be changing to sum here. and this will become y double dash plus z dash. This will give y plus z dash. Now you have to apply it in A. A of x comma y comma z is equal to x into y plus z dash. So apply the multiplication here. It will be x into y plus x into z dash. Now we have to express this particular expression in the form of complete sum of products. How are we going to solve this? We have to list all combinations of x, y, z where the particular expression is going to have true value. We have to make this particular expression true and this particular expression true. In order to make x and y alone true, what values should you have? We need not worry about the value of z. You should have x as 1 and y as 1 to make them true. In order to have the value of 1 for x into y, what should be the value of x and what should be the value of y? It should be 1 for x and 1 for y. Only then you can have 1 here. That is what they say the expression is true. 1 means true, 0 means false. So what are the min terms possible? We will have xy here. They say regardless the value of z, which means z can be in uncomplemented form or z can be in complemented form. So here the min terms will be xyz and xyz dash. Now we will take the second part, xz dash. When you want to have x to be true, you will take the value of x to be 1. When you want to have z dash to be true, it means the value of z should be false. Only when z is false, z complement will become true here. So we apply x is equal to 1 and z is equal to 0 regardless of y. So we have to take the min terms now. X is equal to 1. So we are presenting x as it is. When you take z is equal to 0, you have to mention it in complement form. So it is z complement and z complement. So you have the expression x z complement here. What about y? They say regardless of y, which means y can be in the form of complement and uncomplemented form. Altogether, how many min terms are there? We have xyz. xyz dash is repeating here. Then we have xy dash z dash. So there are 3 min terms totally. This first 2 is taken for xy and last 2 is taken for xz dash. So what will be the complete sum of products? You have to just give sum of all these min terms, xyz plus xyz dash plus xy dash z dash. Which option is having this particular expression? Option number 4. Option number 4 will be the right answer. Next question, choose the correct statement for a group G. So this question is from group theory. If for all x, y that belongs to group G, xy the whole square is equal to x square into y square, then G is commutative. In group theory, a group G is said to have the commutative property if for all the elements a comma b that belongs to G, the operation satisfies a into b is equal to b into a, and such groups we name them as abelian groups. So commutative property is when left hand side is equal to the right side expression as given here. Now we will just work it out for xy the whole square. How can you represent xy the whole square? We can represent it as xy into xy. So this is one expression. How will you express x square y square? This is LHS and this is RHS. Now x square can be written as x into x and y square can be written as y into y. Remove the brackets and write it in this way. How can you say that this particular LHS is equal to RHS? When can this be true? When xy is equal to yx, as we see here in commutative property, we will be able to say LHS is equal to RHS. Say for example, instead of this particular yx, if I am going to place xy, this LHS will become RHS. In case if I am going to place XY by YX, this will become LHS and this will be the RHS. So this particular XY the whole square is equal to X square Y square is definitely commutative only. This condition forces commutativity and so we mark this statement to be true. Without looking the other three options, we can just mark option number 1 to be the right answer because they are asking for the correct statement with regard to this particular group. Now we will go for fourth statement and find what is wrong. If G is commutative, the subgroup of G need not be commutative. We have a statement here. If G is commutative, it means when it is an abelian group, then every subgroup of G is also commutative. If you know this particular property, you can mark option 4 as wrong answer here. That's a fundamental property of abelian groups. Now regarding 2 and 3, x cube is equal to 1, x power 5 is equal to 1. They say 1 is the identity element of G and they have given G is commutative. We have to check whether G is commutative and we have to see whether 1 is the identity element of G. Only when both are going to be true, this particular option can turn to be true. But we know that 2 and 3 are already false. Now we will see what is wrong with 2 and 3. In group theory, the order of an element means the number of times you need to combine the element with itself to get back to the identity element. X cube means you are multiplying x into x into x. This is how we did here. Xy the whole square we multiplied 2 times. X square we multiplied x 2 times and y we are multiplying it 2 times. If x is an element in a group, x cube is equal to 1 means x has an order of 3. The power is what they call as order. X power 5 is equal to 1 means x has order of 5. Here 1 is the identity element. So this statement is fine. This particular property is only wrong. How is this particular property wrong? Saying x cube is equal to 1 means every element in the group when multiplied by itself 3 times gives the identity. So they say when x gets multiplied for 3 times, it results in identity element and when it is multiplied for 5 times, it results in identity element for statement 3 and this is for statement 2. But this does not guarantee that the group is commutative. Even though some elements satisfy x cube is equal to 1, this group by default it is non-abelian. When it is abelian, it is commutative. Only when the property of commutativity comes inside, we call it as abelian group. When they say it is not commutative, automatically we say it is non-abelian group. When the group itself is non-abelian, we can confirmly say that it does not belong to commutative aspect. So from this we can say option 2 is wrong. There exist non-abelian groups, that is non-commutative groups where every element has order 3. Similarly, there are non-abelian groups where every element has order 5. It does not guarantee commutativity is what they say and so this particular option is also wrong. Next question. Let P denote she is intelligent and let Q denote she is happy. Given below are the statements. They have given 4 statements. They are asking which one of the following is correct propositional expression for the above statements. So we have to find the propositional expression of all the 4 statements and then check which of the option is having the right one. In this channel we have a series called CS Connect series. Under this we have mathematical logic playlist and you have propositional logic, propositional equivalences. 2 videos are available. If you go through them when you have time, you will definitely be able to answer this question without any doubt. If she is intelligent, then she is unhappy. Q denotes happy. When it is unhappy, this is negation of Q. P denotes she is intelligent. When they say not intelligent, then we have to go with negation of P. You have to remember this. Regarding propositional logic, we know conditional statement means P implies Q, which says that if P, then Q. Now this is in the form of if P, then Q. But instead of Q here it is unhappy, so it is negation of Q. So this can be expressed as P implies negation of Q. If she is intelligent, then she is unhappy. Happy is capital Q. Unhappy is negation of capital Q. We'll go for the next statement. She is neither intelligent nor happy. What is neither nor denotion? Neither nor means not intelligent and not happy. When both the nots are combined by and operator, at that time we will use neither nor. This explanation is also given in that CS Connect series video. Not intelligent is negation of P, not happy is negation of Q, unhappy or not happy both are negation of Q, and we have and operator here, so we use conjunction operation. So the second expression is negation of P, conjunction, negation of Q. So this is the first one, this is the second one. What about C? It is necessary to be not intelligent in order to be happy. Actually, there are various ways of expressing conditional statements and biconditional statements in English. So in that CS Connect series video, there I have listed all the possibilities of English statements. Right now, to solve this question, I will give you the correct form of this particular statement. If she is happy, they say she is not intelligent. This is the statement that is given in this particular format. It is necessary to be not intelligent in order to be happy. They say if someone wants to be happy, they say that person should not be intelligent. So if you take it in the form of conditional, it is if she is happy, then she is not intelligent. Now you can translate this as if she is happy is Q, not intelligent is negation of P. Since we have if and then, we go with conditional. So the expression is Q implies negation of P. Let's go to D. To be not intelligent is to be unhappy. Here both are giving negation, but the statement is in this form. If she is not intelligent, then she is not happy. This is the other way of writing in English. So you have to know the other forms of English statements, of conditional statements. Only then you will be able to translate both C and D. Otherwise it will be quite difficult for you to understand. Now you can translate this particular statement. She is not intelligent, which is negation of P. She is not happy is negation of Q. When you have if and then, this becomes conditional operation here. Now we have all the four expressions. With A and B, first we will check whether we are able to find the answer. P implies negation of Q is found in 3 of the options. So from this we can rule out option 2. What about B? Negation of P and negation of Q. It is available in 2 of the options. So from this we can rule out option 1 and option 4 also. So just based on A and B, you will be able to mark the answer as option number 3. Now we will just check for Q implies negation of P. It is given here correctly. What about negation of P implies negation of Q? It is given correctly. Next question. Let M and N are positive integers. It means it is greater than 0. There are no negative integers here. Then they have given ABC statements and they are asking which of them are correct here. So let's start with A. If N is not equal to 1, then M is less than M into N. We know M is going to be 1 or any other number that is greater than 0. N is also going to be the same way. If they say N is not equal to 1, N can take any value from 2. M is less than M into N. When you have 1, 1 is less than 1 into 2. 1 is less than 2. when you have m is equal to 2, n value is also equal to 2 because it is not equal to 1. So m into n will be 4. In all cases you have m is less than m into n. So this statement is perfectly true. If n is not equal to 1, then m is less than m into n. Since n is having the value greater than 1, multiplying m by n always increase its value. So m into n is greater than m is always true when n is not equal to 1. They have said m and n are positive integers, which means m is greater than 0 and n is greater than 0, and they say n is also not equal to 1, which says that n is greater than 1. N cannot be equated to 1. When the case is m greater than 0 and n greater than 1, definitely m into n is greater than m, or you can specify this as given in the question statement as m less than m into n. When you say 4 greater than 2 or 2 less than 4, both are same only. We have k is composite in B and D statements. So we will just check with C and then get back to B and D. What about C? If m into n is equal to 1, then m is equal to 1 and n is equal to 1. When the product of two numbers is equal to 1, what are the two possible values here? When you have m is equal to 1, n is equal to 1, you will have m into n is equal to 1. What is the other possibility? When you have m is equal to minus 1 and n is equal to minus 1, in that case also you will have mn is equal to 1. But here they have mentioned m and n as positive integers, which will eradicate this particular possibility. So the only way to get m into n as 1 will be m is equal to 1 and n is equal to 1, which is perfectly true. Since m and n are positive integers, the only way their product is 1 is to have both the values as 1. So this is true and this is true. A and C is included here, A and C is included here. So from this we can rule out 2 and 3. Now we have to understand one thing. Only one of B or D can be true. If k is composite, then k is equal to m into n, where 1 less than m, n greater than k. When you take D, if k is composite, then k is equal to m into n, where 1 is less than m, n is less than k. So this particular criteria is alone changed in both the statements, and we have to find the right one, and only one can be right. A composite number k is defined as the number that can be written as a product of two positive integers, both strictly greater than 1 and less than k. We have prime number and composite number. Prime number is when the number is divisible by 1 and itself. Composite number is when you are able to express it in the product of any other two numbers other than 1 and itself. So when you take 6, it's a composite number. How can you express this? 2 into 3. You are expressing it in the form of product of two positive integers. So when you take 10, it is 2 and 5. When you take 2 and 3, are they greater than this particular k or less than k? Both are actually less than k. This k is the composite number here, and these values are m and n. When you take m and n, both are actually less than k is what they say. If k is equal to m into n, the product of two positive integers, then 1 is less than m is less than k. It means m can have a value from 2 to k minus 1, 1 less than n less than k. N can be expressed from 2 to k minus 1. In both the cases, 1 is excluded and k is excluded. When a number is divisible by itself and 1, that becomes prime number. Except then, everything is composite number, means those two numbers are taken out. So 1 and k are taken out. Anything between them can be the range. This means that neither m nor n can be greater than k. In that case, this particular expression fails, and so we know B is definitely false. So the option that includes B can be ruled out. The expression is actually 1 less than m, that is m is greater than 1, and m is less than k. This can be written as 1 less than m less than k. What about 1 less than n less than k? This can be expressed as 1 less than n less than k. So this condition is expressed here and this condition is expressed from here. So this is right, n less than k is also right, but this one is wrong. So D is also right, so we are marking it to be true. So option number 1, ACD will be the right answer, and I have told you why B is false. If D is true, then B is definitely false. Next question, match list 1 with list 2. We will first understand what is inverse, converse, contrapositive. Conditional statement means P implies Q. So it is if P then Q. What about contrapositive? Negation of Q implies negation of P. This can be expressed as if not Q then not P. What about converse? Q implies P. If Q then P. What about inverse? Negation of P implies negation of Q. If not P then not Q. Converse is actually swapping the original conditional statement, and contrapositive is logically equivalent to the original statement. So let's take P is equal to true and Q is equal to true. They say if P is true, Q is true. What is negation of Q? It is false. What is negation of P? It is false. So I am just swapping the places and giving conditional. They say if Q is false, then P is false. So the same statement is written in negated terms, that is contrapositive. So both these statements are actually logically equivalent is what they are trying to tell. There is a big challenge here. We don't know what is P and what is Q. They have given two statements here. Indian team wins, and the next one is it is raining. One should be P and one should be Q. Indian team wins can be taken as P and raining can be taken as Q. We will start with this. We will check whether any of the option is actually matching. If not, we have to take Indian team to be Q and raining to be P. So first we will start with Indian team wins to be P. So when it is not winning, this will become negation of P. When it is not raining, this will become negation of Q. If Indian team wins, it is P, then it is raining, it is Q. So P implies Q. What is P implies Q? It is conditional statement which is mapping to option 4 in list 2. Is A4 available here? No. Which states that our choice of selection of clauses is wrong. Indian team wins becomes Q and it is raining becomes P. So negation of Q will be not winning and negation of P will be not raining. In one of the earlier question they have mentioned this is P and this is Q clause. So we were able to find the expression in a quick way. But here we don't know what is P and what is Q. Just based on these 4 options only, we will be able to find which is Q and which is P. If the Indian team wins, if Q, then it is raining means then P. What is if Q then P? It is Q implies P. What is Q implies P? It is converse. A will be mapping to 2. Is A2 available here? Yes, it is available. So definitely Indian team will be Q clause and raining will be P clause. Since we don't have the combination of A4, we are ruling out P as Indian team winning and Q as raining. We are not selecting it because we are not given A4 as the option in any of the listed options 1, 2, 3, 4 here. That's why we are taking Q is equal to Indian team wins and P is equal to raining. Now let's get into B. If Indian team does not win, it means if negation of Q, then it is not raining, then it is negation of P. So it is negation of Q implies negation of P, which is contrapositive. B is mapping to 3. B3 is available here. We can rule out 2 and 4 from A itself. And now we are even ruling out option 1. What about C? If it is raining, if P, then the Indian team wins. It is then Q. This is the perfect conditional statement. P implies Q. C is mapping to 4. What about D? If it is not raining, if negation of P, then the Indian team does not win is negation of Q. So negation of P implies negation of Q is inverse. D will be mapping to 1. Option number 3, A2, B3, C4, D1 will be the right answer. With this we are completing Unit 1 questions.